on investment and also net present value. Okay, so the problem would be new machine. We can say machine A and machine B. They're both available and are available for $80,000 each. Earnings after taxation are as follows. So you have year 1 through 5. So machine A would be, first year would be $24,000. Year 2, $32,000. Year 3, $40,000. Year 4, $24,000. And year 5, $16,000. Okay, so going over to machine B, the first year would be $8,000. The second year, $24,000. The third year, $32,000. Fourth year, $48,000. And the fifth year, $32,000. Okay, so let's talk about this. So you're required, what you want to do is you want to evaluate the two alternatives using the following: A, the rate of return on investment method, and B, the net present value method. Okay, so you should use a discount rate of the standard 10%. Okay, these are the particulars of machine A and machine B. So the total cash flows are $136,000. So the total cash flows are $136,000 for machine A. The average annual cost, I'm sorry. Okay. So I think we should pause. I got it, don't worry. We'll just edit this out. All right. So the solution, the rate of return on investment method, the particulars are for machine A. So the particulars for machine A are the total cash flows, $136,000. The average annual cash flows, $136,000 divided by 5. And it's going to give you $27,000. The annual depreciation is $80,000 divided by 5, and this will give us $16,000. The annual net savings would be $27,200 minus $16,000, and this is going to give us $11,200. The average investment is $80,000 divided by 2, and we're going to get $40,000. And the rate, the ROI, or rate on return, the annual net savings, average investment times 100. So it looked like this. So look, $11,200 will divide it by $40,000 times $100. And then this is going to give us 28%, right? 28%. So if we look at what we have to contrast it with, which is machine B. So the total cash flows for machine B is $144,000, and the average annual cash flow for machine B would be $144,000 divided by 5. This is going to give us $28,800. And we'll do the annual depreciation would be $80,000. We divide this by 5. It gives us $16,000. Annual net savings, again for machine B, $28,800 minus $16,000. It's going to give us $12,800. Average investment would be $80,000. We divide it by 2, we get $40,000. ROI, the annual net savings, divided by the average investment times 100, right? So 12,800, we divide by 40,000, multiply by 100, and we get 32%. So if we had to make a financial decision based on this data, then we go with machine B at 32%. So now let's talk about the net present value method. Okay, so the idea of this method is to calculate the present value of cash flows, right? So money, we talked about money has a present value and a future value, right? So we're talking about what does this work? So we have year 1 through 5, and again we use a standard discount factor at 10%. So let's take a look at machine A. So the cash flow is $24,000. The present, all right, Arthur, let's take a break. Let me know when. All right, so we take a look at the net present value method, okay? And the idea of this method is to calculate the present value of cash flows, right? So we have, again, year 1 through 5. You see that on the table, we have the discount factor at 10%. Starting with year 1 would be 0.909, right? So if we take a look at machine A, we would do 24,000 times 0.909, and we get a present value of $21,816, right? So year 2, we'll do 32,000 times 0.826, and we get a present value of $26,432. Again, year 3, $40,000 times 0.751, we're going to get $30,040. Year 4, $24,000 times 0.683, we get $16,392. Year 5, we have $16,000 times 0.621, and we get $9,936, right? And so if we want, so we take a, let's take a look at machine B. So it's year 1, $8,000. Again, we do times 0.909, and we get present value of $7,272. Year 2, $24,000 times 0.826, we get $19,824. Year 3, and you would basically follow the same process like we followed for machine A. So the net present value of machine A is 4,616 minus 80,000, which equals 24,616. Net present value of machine B is 103,784 minus 80,000 equals $23,784. So according to the net present value, or NPV, machine A is preferred because its NPV is greater than that of machine B. So it's we can say it's a better, based on the numbers alone, it's a better financial decisions. So thank you very much for watching. If you have any questions, feel free to send us an email.